Welcome to another episode of XinaBox Daily. So today we're gonna start a series of XinaBox daily shows that focus around Python, programming Python on our course. So today's setup, so you can get into programming your course. So here is kind of like the environment. We're not going to go into strict programming, but just how the different cores operate. So we're going to look at the CW2, the CS11, and the microbit here. Not that the microbit is one of our cores, but it's easy just to include it here. And we're not going to use any other xChips. That's coming in later shows. And how the some of the built-in functions, like there's Wi-Fi and there's SD card here and so on, with that we also only going to include on a later stage. So today it's just like, how do I get ready? How can I get to the point where I can program my first line of Python code with these? Okay, so here on the screen I have CircuitPython, and I also have a tab here with our GitHub page. And on the top of GitHub, there's an XinaBox uploader we're gonna need for the CW2, and there's a version of the MU editor that are done so we can use the MU editor for our devices. That MU editor have like a few changes compared to the official MU editor that's out there, which is necessary in order to use our devices, and it might on a later stage be aligned with the official version of the MU editor. But for now, if you want to use our devices, you need to use this version here. So let's start with the MU editor, because that's actually the first thing you have to get up and running. So if you click on MU editor here, you get into a little page and there's a release. And inside the release are the Apple version, the DMG, and there's a Windows version, 64-bit Windows version. If I go back to the main page here, you can also directly download the Mac OS version here and the Windows version here. I haven't done a 32-bit version for Windows. If there's a requirement for that, I can't imagine, but if there is, I can of course make one. So we have these two versions. I'm working on a Mac, so you will see the Mac version of mine. It's straightforward. When you download the DMG here, it comes up with the standard little windows where you have to drag your app to applications, and if you're on an Apple machine, you know exactly what I'm talking about. And this one have like an installer where you click the installer and it puts the MU editor inside your Windows environment, and you can see it in latest install and start it up there. So I'm not going to go into details on how to install this. It's like installing any other software on the environment you're used to. So I assume we can skip to that. But this is just where you find it. If you find a MU editor somewhere else and you use the official MU editor, it will only going to work with your microbit. It's not going to work with the other cores. So back to our main website at github.com/XinaBox, MU editor. An XinaBox uploader is important in order to get the CW2 up and running. So what I'm gonna do is I'm gonna start with the CW2 and get that ready. So the CW2, it's straightforward. I'm plugging into my computer, as you can see here on the screen. And then when you install the XinaBox uploader, again, there's various versions here. And you can then use the latest version to install the latest versions of MicroPython. So let me start the XinaBox uploader. We have it here. And it starts up, and you can see it blinks a little bit here, and it knows the CW2. And what you do is you choose MicroPython. Now I put a date in there just so you know which version it is. So this is like from the 22nd of April. So we don't update them too often, like maybe every half a year. So this was updated here in April. If there's like major changes or release or things like that, or a request, of course, we can update it more often. You can also install this yourself. There is like on MicroPython page, which I'm showing you just now, there's a way to do this. But obviously this is like much easier. It downloaded the app and then it flashing the app to the CW2. So you can see the lights flashing here on the CW2, and it's now uploading this thing here to a CW2. If you put a CW1 in, there is a similar download for the CW1, and you can also program the CW1 in MicroPython. However, the MU editor and the standard IPO1 doesn't work quite yet. So therefore, I'm not suggesting you do this with the CW1. If you have, for any reason, an old IPO1, you can use the CW1 because there's a switch here on the old one where you can flip the switch here from B to A, and then you can actually use the CW1 and MicroPython here. So in MicroPython, you will see reference to CW1 because we try to see if we can get it to work with our standard IPO1, but just that's the difference. Anyhow, we finished here, so now that's installed. So this one here is now ready, and just to see that it's ready, I'm now going to start up my MU editor, and it had detected that we have the CW1 device here. So this is how the MU editor looks like. There's a lot of other documentation about the MU editor, so I'm not going to cover everything with the MU editor again in this episode. It's a very, very clean interface to program in Python. There is other ways of editing and programming Python on our course. I'm focusing on this thing here simply just because it's clean and easy. So the two buttons you have to look at is around here. I say around here because not all the cores have files and REPL. Some have like something called serial. But if it's serial and REPL, it normally means you can talk to the device. So if I click here, you can see on the bottom of the screen here, it says MicroPython, and it says ESP32 module because our CW2 is based on the ESP32. And just to see it works, I type in a MicroPython statement like 3 times 6 and press enter, and it press 18. So there we have it. I wouldn't say we necessarily hadn't made a program, but I'm coming back to that. So that is the that is the CW2. So before we continue with the CW2 here, then let us get the CS11 ready. So I'm gonna take that away, and the CS11 we don't use the XinaBox uploader. Instead of the XinaBox uploader, we put them into programming mode and we download the UF2 file that we then put in. So let's start with taking the CW2 out, and then I have this little short cable here that allows me to plug this in to my cable. So now we have it here, and then sorry. Then in order to get it into programming mode, we have to double click on the reset button, and then there's a light here. It's blue. I don't think you can see it on the screen, but it's I promise you it's blue here, and that allows it to put it into programming mode. And to see it's in programming mode, we have to look at our file system and see it comes up as a CS11 here. So now that is in programming mode. So now we just need to get the UF2 file. So if you go into CircuitPython here, so circuitpython.org, it was originally developed by Adafruit, I believe, as a branch of MicroPython. So it's kind of like MicroPython, but it has a few changes here. So straightforward. You go into downloads, and then there's all the different cores. And what you can do here just to find ours is you can just say XinaBox, and then you can see here's the 2 cores. So here's the CS11. So if you click on that, you can see here which version it is, and there's a little bit more here. So there's like the 5.3 version and the 5.4 beta. So we're gonna take the 5.3 version here and download. So I have it here, so now it's downloaded. So if I say show in Finder, then I have the file up here. I have a couple of other files that I have downloaded before, and I simply just drag and drop, and you can see I have another one at the bottom here, but this is the one I just downloaded. So let me put that in here, and now it's plugged in, and it comes up in my file system now at CircuitPython. So the light here switched off. Don't know if it's visible compared to before, and now it's in CircuitPython mode. Okay, now if I double click on it again, then it goes into programming mode, and it changes up back to CS11. You can see here, and if I just press single reset, it goes into its Python mode, and you can see it says CircuitPython here. So that's how you change between the 2 modes. Now we have CircuitPython here, and I have a couple of files that I had put in earlier, so I'm gonna take them away here just to not confuse it when we use it. So this is normally how it's gonna look like when you download it. So I'm gonna now go back to a MU editor, and you can see here now in the MU editor they say it detected a new device. So when you change between the devices, it automatically then also show the device in MU editor. So you say okay here, and now you can see up here you don't have a files, and you don't have a REPL, but you have a serial. And when you click on that, you can see you get the same result. I have to press enter here, and you can say it says XinaBox CS11, and we come out with a equally interesting problem to solve, and it comes out here, and I do a little bit of math. So you can see here we now have the CS11 programming. Okay, and then the last one, which is straightforward, is the microbit. Now that have Python installed already, so you simply just plug it in. You don't have to have our bridge on the bottom for using the Python here, but later on when we gonna start using xChips, obviously you need this. And you can see similar here, it comes up and say detect a new device. Now it's a microbit, and you go in, and the microbit runs MicroPython similar to the CW2. So whatever we do in a CW2 will be the same as in a MicroPython here. So here similarly it comes out and say it's a microbit, and just to show it works, we take another problem here to solve, and it does that brilliantly too. So now we have the 3 different devices. We have in these 10 minutes managed to actually flash the Python to our cores. It's already in microbit. We installed the MU editor, and we have now have the devices ready. So there's a little bit of difference how they work from here on. So in order for me to tomorrow kind of like focus on one core, I'm not gonna show the same code 3 times over for the different devices. So I'm just gonna show here how they're slightly different. And of course there's some stuff where they're very different, like, you know, the CS11 doesn't have Wi-Fi, but the CW2 have, and so on. And of course when I'm going into those details, I'm only gonna do it on that specific core. But there's a couple of things that is the same on all 3, it just works differently. And that's like the file system, the way that you want to use the file system on these ones. So I'm gonna go back to the CS11 as the first one here, and then I'm gonna show it on the CW2, and that's of course the same as on a microbit. So here's the CS11. and it comes up here and say this one is gone, this one is gone. We detect a new device, and here we have it. So here is the device. Now on the CW2 we have something called files and a microbit that files. We don't have that here. So what you have to do is you have to use your file system, because your device comes up as a file here. So here's your CircuitPython here, and we have some code here in mycode. So we have, for example, test and welcome. Okay, so what I'm gonna do is I'm gonna take this welcome here and I'm gonna put that into CircuitPython. And then we have so that's a text, and that text is being used by my test program that I also drop in here. So now when I look here, I have the two files loaded into my device. So if I'm going back to my MU editor here, I can load up a program. So I can load up my test program here. So my test program do here, it says with open welcome text as a file, read the file, print the data, and then print the end. Now this is a very standard way of reading files in Python. You can do it different other ways, but this is like the correct way of doing it in Python. And I'm just using this to actually show, and it's the same code I run on all of them, because this is actually, you know, straightforward Python. But this is just to show how the file system works. So if I go into serial here, and then I can actually say import, and I just want you to see here, it says Control D to reload, and this is important because when we run a program, so the way I run the program here, and there's many ways of doing that, I'm not getting into the details, I say import test. So I'm taking not the one I have up there, but the one I have on my file system, and I run that, and it writes out what's inside that welcome.txt file, which is a lorem ipsum, and then it prints the end at the end. Now if I do it again, like you can see here in the bottom, then nothing happens, because it actually it's a part of Python where it's like have gone to the end of that file, so you know, and the end of the program. So if you want to reload the whole thing, you simply say Control D, and it says there again if you have to reload it, so you do that. So it's kind of like a soft reboot, and then you can of course say import test again. So just when you play with this thing here, you don't really understand why things not happening, things like that, you can do this soft reboot. So this is a soft. You can also press the reset button on your device. That's hard reset, hard reboot. Now a cold reboot, if you can. Well, it's not a really cold, because cold is when I take the power out, but it's not soft, it's hard reboot. The last thing is that you can save this like I think main.py or something like that. I'm getting into that later on, and then it will run automatically when I reboot my device. But because I want to program this thing here, and I wanted to get into my interpreter every time, I'm not actually having it running as the program that runs automatically when you reboot the device. So here it only runs when I started to run, but you can actually take it and just by giving the right name, every time it starts, it actually reruns this program. And if you, for example, have a sensor and you want to store the data on an SD card or send the data out on display or whatever, then of course every time you reboot it, you just want to have it to run over again. So that was the CS11. Now let's do the same thing with the CW2, and that's slightly different. So I'm gonna unplug that here, and then I'm gonna take my CW2 in, which I have here. And you can see on the screen it now says I detected a new device. It's a CW1 or CW2. So we say OK. So the code here stays the same up here at the top. But now I have my REPL where I can actually say, you know, print something like that. Or I can go into files. It's grayed out because I'm REPL, so you can't click on it. So you first have to close that, and then you can see that's available, and you go into the files, and something happened. Let's try again. Just make sure we are not covering it. So files. So here we have the files. So this is the files on my computer. So test py and welcome text is on a file that's called mycode. So my has like, it says where's the files on the computer, it's in mycode. So if I go to my folder system and I go down to mycode, you can see it's actually underneath my username. My username here is bg, so mycode is here, and there's the two files. Now the my editor automatically creates a lot of these, not the old one, but a lot of the other folders here, but it only shows the data in the root of mycode. So this is what I have here. So the CW1 and CW2 is not available out here, so you can't see them in the file system here. So the file system is not available like it is with the CS11 out in your on your drive, on your disk drive. So instead you have to have this file system that's built into the my editor. So that's good or bad. You know, if it's on the outside, you can actually generate file and drag them out without actually running my editor. Here you have to run my editor, and you can do the same thing. You can move files forward and backwards. So I have two files here. So I'm dragging one at a time over here, and you can see they're getting copied over to my device. Now I want to run them, or actually I want to go into REPL here instead. I can't because I'm in files, so I close that. Start this one here, and now similar to before, I can say import test. And you can see it runs test. It runs it with that text file I have. So we have a program running by dragging this over. Now I am actually interested in just if I can do import test again. I can't. So in this case here, I also have to reload. So I did that with Control D, import test, and it worked brilliant again. So that is the way that it works on these devices. The way it works here with the CW2 is exactly the same on the microbit, because the microbit is also running MicroPython. So the last few minutes, I just want to talk about what is the difference between normal Python and MicroPython. And the best place to go is that if you go to micropython.org. So micropython.org have like documentation and download. And a way, if you wanted to download a newer version, then you can go in here and say download, and it will show you the files here for the different devices. The pictures, this is a generic ESP32, but if you look at the back, you can see that's very much the same one we have on the back of ours here. Ours is of course just encapsulated in our ecosystem, but you can download this thing here and you can start reading up how you're actually gonna program that. I think if you click here and you say I want to program it, it talks about downloading something ESP tool, and you have to write this statement here. And there's a number of different versions. There's something that do you know, there's unstable versions. There's like a lot of different versions here. So we kind of like try to find something that's stable, put it in, because that is of course the way that we want the user to have the impression of that. But if I go away from the download here into the main page here, then the documentation here is probably the most useful on this website. And that is, you find it here. So the part that is going to be the first interest, if you are experienced Python programmer, you might want to read up at MicroPython, different from CPython. CPython is the term for our standard Python, and the MicroPython implements 3.4, 3.5. Of course, it's going down. We are now in 3.8 in CPython, and this is like slightly behind. In this list here, it tells about how you get different results in CPython versus you get from the standard libraries that you have here. So just remember that I'm sitting on a computer that is like 50 times bigger than the CW2 here. It have like a terabyte of data and tons of memory, and it runs on a mains power. This one here have 4 megabyte of total storage. So the CPython, the MicroPython have to be in here, your program had to be in here, the code to execute and all that kind of stuff have into there. So MicroPython is smaller than normal Python, hence micro, and there will be certain things you can't do in MicroPython which I can normally do in CPython. I think it's limited. There's a lot of stuff you on the other hand can do because now you have access to external devices and so on. If you want to know especially what CW2 can do, then down here you can see there is like a reference to ESP32, and even though the picture is different, then the functions here are exactly the same. So the only difference you have to be careful about when you read here is that there's different pins in use. But like Wi-Fi and all that kind of stuff doesn't come out. So it's only pin in use is I2C, it's UART communication, and it's the RGB LED here. And we're going to document that separately for Python. So you have a sheet where you can go in and find how that is. And we're going to build that as we build up this series XinaBox daily. But you can see here, if you want to communicate Wi-Fi and you can program Python, well, then you can get the Wi-Fi up and running here. You have the sleep functions, you have pins and GPIO, and again, we need to just document for you where the pins are for the different LEDs and things like that. And then you have like number of things that's not available on our device because we haven't taken those pins out. So like the PWM, the ATC, and things like that is not available. The I2C bus is here, and there's some pins that are referred to. Those pins, again, we're gonna give you tell you which pins that is. But here you have the documentation for ESP32. If you are lucky enough to be able to program the the CW1, then there is a quick reference for the CW1, similar here as you had to the other one. And you don't have to have the MU editor to program these devices. You can also program them using Visual Studio Code. There's like a plugin for that. I'm going to cover that on a later stage. You can even use a standard browser or terminal for programming that. So I have, for example, a cool term. So if any of you are used to like PuTTY on a Windows or cool term or something like that, then you can actually go in and you can program the device. But you don't have the same access to the file system and all that kind of stuff. So it's not exactly the same. I go in here and I have to define the device. And I'll go in and say, I don't want to have these connected because that's the one that kind of like interferes. And if I do that with the CW1, then I can actually program the CW1 from, for example, cool term here. And then I connect. And then you can see here it's running. So I can now say print 3 times 7 and this at 21. So I'm now actually talking to that device. But so you can program this from a multitudes of places. The MU code is an interesting and nice one because it have this file system built in. You don't have to define everything, but just to show you that you can actually use any kind of browser. And that goes with the CW1 obviously also, that to program these the devices here. That is it for this episode. I'm gonna continue again tomorrow with a little bit more getting in depth into how to program some of these. So let me just also end saying this is not a Python programming class. I'm not gonna teach Python. There is probably 1 million videos on YouTube where you can learn anything about Python. So I'm merely just trying to make sure that the Python skill you need access to, you have already, you can use to get access to Python on these devices and make sure that you get the most out of programming Python on these devices here. So that's it for me. I hope you enjoyed the show, and I'll see you again.